In this video, we are going to see how to obtain data that are related to other data, crossing them. Remember that in our KB we had the attraction transaction, which allowed us to record attractions in different countries and cities. And we also had the tour transaction, with 2 levels, which recorded the different tours that the travel agency offered to visit different tourist attractions. To register the tour attractions, we had the second level, named attraction. If we run the work with of attraction, we see these 3 attractions, 2 from Paris and 1 from Beijing. And if we run tour, we have only 2 tours entered. The first one with the 2 Paris attractions, and the second one with the Beijing one. Let's enter another tour, which we will call like this. And that will only visit the Louvre Museum attraction. With this, we can see that clearly that attraction will be in 2 different tours. In this one, 3. And in tour 1. We have then these 3 attractions in the attraction table. And if we represent the table of the second level of the tour transaction, we have 2 records for tour 1, those for attraction 1, Louvre Museum, and attraction 3, Eiffel Tower. 1 record for tour 2, with the Great Wall attraction, and 1 record for tour 3, with 1 attraction, Louvre Museum. So how would we calculate how many tours each attraction is on? By running through the second level of tours, i.e. the tour attraction table, and counting the repetitions of attraction id. For Louvre Museum, there will be 2. For the Great Wall, it will be 1. And for Eiffel Tower, it will also be 1. So, for example, if we create a web panel with a grid to list the tourist attractions, where, in addition to the ID, attraction name and country name, we want to list how many tours each one appears in. We would place this code in its load event, where we still need to determine how to calculate the value to assign to the tours variable. We just analyzed that for each attraction in the attraction table, we would have to run through the information of the attractions of the tours, filtering by the attraction id. Another way of saying the same thing, we would have to group the records that have the same attraction id, in this case, to count them. We could then consider placing another for each here, nested inside the first one, where we can count the records that meet this filter. The first for each, the outer one, navigates the attraction table, which is the table associated with the attraction transaction, named here. And for each record in the table, it will execute the internal code, which is all of this. Then it will associate to these variables the values of these attributes of the base table itself, and also this country name of a table of the extended one. And then it will assign 0 to this variable. And it will execute, positioned in this record of attraction, this other for each, that, as it is indicating as base transaction the attraction level of the entity tour, we know that it will navigate this other table, which is related to that of attraction, precisely through the attraction id attribute. It will run through this table, filtering the records that correspond to the same attraction id of the attraction table in which it is positioned, adding 1 to the variable for each of those records. After the for each completes, a row is loaded into the grid with the values of the variables. We say that when we perform this information cross-check, where for the record of a table we run through another table filtering in it, according to some criterion coming from the record we are working with in the first table, we are performing a join operation. So with these 2 nested for each commands, that is, one inside the other, by filtering on the nested one according to something related to each iteration of the main one, we are performing a join. Here we have already created the web panel with the 4 variables in the grid, and its load event programmed as we showed before. Let's ask to execute. Let's analyze the navigation list before testing. It reports on the nested for each command. First, the entire attraction table is run through. Because we didn't specify any filter, country is accessed to retrieve the country name. And for each attraction found, this nested for each appears, which runs through the tour attraction table, retrieving only the records that have that attraction id. We see here the ampersand that is indicating the variable of that name. Note that the processing is optimized because as attraction id is a foreign key in this table that points to the attraction table, it has an index created. And it is the one that it suggests to use so as not to run through the entire table. If we now execute, we see the 3 attractions, where for the Louvre it counted it in 2 tours, the Great Wall in 1, and Eiffel Tower also in 1, just as we expected. Now, what would happen if we remove the explicit filter by attraction id? Let's try. We see that the navigation list is almost identical to the previous one with the explicit filter. The only difference comes from this @ sign. Earlier we saw the ampersand of the variable. What does this @ sign correspond to? It is something inferred from the context. This @ sign represents the value of the attraction id attribute of the iteration of the for each in which this other one is being executed. In other words, it applies the filter without having to state it explicitly. To confirm this, let's run it and see that the result is exactly the same. What we have just tested is very important. GeneXus automatically performs the join without having to make it explicit. This is because it knows the relationships between the tables and assumes, therefore, that we will only want the related information. As we saw in the video in which we implemented a procedure as a function, here we could also replace this for each that we implemented to perform the count with an inline count formula, where we don't have to specify the filter condition either because GeneXus infers it. We need to indicate as attribute to be counted one that corresponds to the table of this same base transaction. The associated table only has these 2 attributes, which make up the primary key. That is why we choose one of them, tourid. Since this count formula is inside a for each that navigates the attraction table, each iteration has a specific attraction id. Then, since the formula will have to navigate the tour attraction table, it works as an automatic filter for its navigation, and that's why the join is being performed inside it. If now we test it, change in the nested for each for the count formula with the tourid attribute, and we ask for the navigation list. We see that now there is only one for each attraction. But for each attraction, indented here, we see that it will navigate the tour attraction table to resolve the count formula. So, if we now execute, we should get the same result as with nested for each commands. The case of nested navigations we have studied so far can be formalized as follows. The first for each navigates a specific table, in this case attraction. And for each record in that table, it has another nested for each that navigates another table, which is related to that of the for each in which it is located by a many-to-one relationship. That is, for each record in the table of the outer for each, there are n related records in the nested for each table. The relationship in our particular case is given by the attraction id attribute in this table, which is a foreign key to this other one. It is this 1-to-n relationship between the 2 tables that makes GeneXus consider that for the nested browsing, we will want to retrieve only related records. And so it performs an automatic join. And if now in the outer for each we run through the airports and in the nested, for each we run through the attractions, we know that the airport has a foreign key to the cities table. which needs the country table to exist. Country, city, and country are in the extended table of airport. So, in the outer for each airport, there will be access to one city record and one country record. Attraction also has a foreign key to the city's table. So an attraction will correspond exclusively to a city. And given a city, it can be in n attractions. Therefore, for each airport, we have one city and n attractions in the same city. Then GeneXus will perform the automatic join. So, for example, let's suppose that in a web panel with this grid containing variables, we load the rows with a for each that runs through the airports and in each iteration accesses the values of these attributes of its extended table. If what we want is to count the number of attractions in the airport city, we only need to write this or use the similar count formula. So here we have created in GeneXus a diagram of these tables, and here we have a web panel that implements what we just described. By specifying it, we see that the first for each navigates the airport table, running through all of it, and accessing country to retrieve country name, and country city to retrieve city name. And then it iterates in the nested for each over the attraction table, applying these automatic filters by country ed and city ID. Since these two attributes constitute a foreign key to this other table, the filters are applied, where the @ signs indicate the values of those attributes, but for the record of the outer for each in which we are at that moment. In short, from airport, we get one city and only one, which may appear n times in the table of attractions. When GeneXus does not find this 1-to-n relationship between the information of the nested navigations, as in this case for example, where the outer for each navigates airport and the nested one customer. For each airport record, all customer records are retrieved because there is no obvious relationship. When GeneXus does not perform an automatic join, then it is said that what is performed is a Cartesian product. There is a third case, which is when both navigations are performed on the same base table. For example, to group airports by country. This case is known as a control break, but we will not deal with it in this course. To conclude, when we talk about nested navigations, we are not only referring to the case of two explicit for each commands, one inside the other. For example, we saw a case of a for each with an aggregate formula inside. But it is also valid for the case of a grid with a base table and a for each or inline formula in its load event. That is to say, if instead of the variables, we had here the attributes attraction id, attraction name, and country name, which would determine that the grid will have attraction base table. In that case, there is an implicit navigation, that of this table. The load event will be executed automatically once for each record of the base table to be loaded. So if we put this for each in there, it will be nested to the implicit one. Let's create a new web panel. Let's insert in its layout a grid with these three attributes. Let's insert a new variable, tours. With this, we already know that the grid will have attraction as its base table, but to be sure we can specify the base transaction. Then we write the load event with the for each. Let's run it. In the navigation list, we see that it is reporting how grid 1 is loaded, running through the attraction table, going to country to retrieve country name, and the explicit for each is nested, performing the automatic join by attraction id. If we test it at runtime, we see exactly what we expect. We will get the same navigation if instead of the for each we use the count formula. We've seen how we got the same nested navigations with 4 variations of the same case, with 2 explicit nested for each commands, with an implicit one, that of the grid, and the other nested in the load event, with a for each and an aggregate formula inside, or with an implicit for each, that of the grid, and an aggregate formula in its load. What we intended to show is that, regardless of which particular case of nested navigations is implemented, when the navigations are to different tables, GeneXus will look to see if there is a one-to-many relationship, direct like this one, or a little more indirect like this one. To, in that case, perform an automatic join. That is, for each record in the main navigation, in the nested navigation, only consider the related records. Only when it doesn't find that somewhat direct relationship will it perform a Cartesian product. That is, for each record of the main one, it will run through the entire table of the nested one. Finally, we mentioned one last case we didn't go into, which is that of navigations on the same table.